Our names are here at the beginning of the slideshow, and it will be shared with everybody at the end. So we began this project working on what's called the feminist controversy in England. And I would just like to explain how the project began, both in terms of computational thinking and historical and literary thinking. And then Kaylee will show you all the steps we've gone through to work on the project, beginning with the project manager, Kaylee Hart, and our lead developer, Brian Tarpley. I started working on a grant called Text Mining the Novel that was funded for 6 years. And about 2 years in, I got pretty frustrated with the fact that all the text mining that was being done for this project was really coming back with stereotypes about women. And so I joined a group of women researchers who are very irritated by this. You can see this ACL from the first workshop on ethics and natural language processing, very important essay. These are not the stereotypes you are looking for. And mine, cultural analytics, which is basically text mining on cultural data, finding or making stereotypes. The stereotypes, moreover, do not prove true across data sets. So it's something in the mind of the beholder or the algorithm designer or something, or data designer. So we want to do something different. But one of the things that I noticed is that the text miners I work with really love doing gender analysis because there's two for them, M and F, and it's really much easier to get an algorithm to predict correctly if it's got a 50-50 chance. But of course, there aren't just two gender categories, and arguably, if you read through the history about sex and gender, there never have been. And so Facebook in 2014 added custom gender categories. And it's absolutely not helpful if you're trying to do something computational, because there are just 50 of them or 60. And not only that, but the categories, some of them have the same subsets. So, they aren't really helpful. It's more of a taxonomy. My favorite is non-binary, which covers everything. And then other, well, what else would there be? Binary or non-binary, but whatever. And here the list goes on. The other problem for us is that if we were to use contemporary gender categories developed in the 21st century, we would not be doing historically accurate research, because that's not the names for genders that, and not the way of thinking about gender that writers in our period, were accustomed to. In the 18th century, we have terms like Amazon, Sappho, and Virago for women, fop, Molly, link boy, man of feeling for men, and romantic friendship really for lesbians. But the link boy, for instance, that category really only lasted 150 years, and man of feeling only 50 years. And we have documented in letters when people just started laughing at it as opposed to really finding it inspiring. And romantic friendship, I think only about 200 years. So these are very culturally specific moments, and you can see that different kinds of genders emerge at different culturally specific moments. Now, how do we know as 21st century scholars that these terms emerged? Well, it's part of the research that people do and have been doing since the 1980s with Alan Bray's Homosexuality in Renaissance England, which documented the Molly. Then just in the last 2 years, men of feeling, a new kind of gender category, which we've always known about because it was a really big movement. But basically, and the Sappho book is Dangerous Intimacies, but basically what these scholars have done is they've just read a lot and found these terms coming up and then analyzed where they come up. So of course, with computational methods, what's really exciting is you don't have to be limited by one scholar's, capacity to read and remember and take notes and organize them. You could use computational methods to run over innumerable number of texts from the period. The only sort of digitization project that really resembles what we're trying to do is by, let me just get her name here. It's Stephanie Prosavec. And she kind of did what we're doing, but we're doing it digitally, where she went through, sorry. On the Road Again by Kerouac. And she went through and hand encoded parts of it and then presumably entered those into a database and generated this visualization. We have no record of her encoding other than screenshots. We have no code on GitHub, nothing. So it's really not very useful. And in fact, she sells these images as prints. So that's the plot shape of On the Road Again. Really isn't so very interesting intellectually, I think. So let me just tell you a little bit about our data set. I began wanting to digitize a series that was published by Garland Publishing in the 70s by Gina Laria Walker, early feminist recovery critic, 44 titles in 90 volumes. And these titles are both novels and essays. And the essays are, in fact, usually about the rights of women because it became between 1788 and 1810, when everybody was writing to defend democracy and consequently equality. Of course, women started thinking, well, what about gender equality? So the big text during this area that you all may know of is Mary Wollstonecraft's Vindication of the Rights of Woman. Here she is, 2 images of her painted by John Opie. She also wrote a book called Vindication of the Rights of Men that was published right in the same month with Thomas Paine's Rights of Men by the same publisher. There was a big hoopla defending the French Revolution in 1790, 1789 and 1790. 2 years later, Mary Wollstonecraft wrote The Vindication of the Rights of Women. And you can see this is a Boston reprint, but it made it across the ocean pretty quickly. So the original is published in England in 1792. This is an image of Mary Wollstonecraft presenting her rights of woman to freedom. And it was circulated around the time. I'll just give you a sense of why we think in these volumes we might be able to track gender categories that never were fully normalized by anybody, but are just imagined by these women writing during this time as more egalitarian and consequently liberatory for women. So what Mary Wollstonecraft says in a very famous quotation is, "It is time to effect a revolution in female manners." She says, we've been, debunking the tyranny of kings. Let's debunk the tyranny of men over women. I want to effect, she says, a revolution in female manners. And then she defines female manners as local. So a lot of literary theorists say she's talking about ideology. And the historian Lynn Hunt says this is the first time the concept of various, political groups having ideologies comes into existence. So I will just say that the terms that we want to find are generated as novels and essays discuss women's potential futures, a kind of utopia or dystopia of equality. So our question is, what if we could, with the help of machine learning and NLP techniques, allow their gender terms to emerge from this large data set. And so now I'm going to turn it over to Kaylee, who will tell us how the data set has been prepared. Kaylee has been project manager and worked for the project the whole time. We had 6 years of grant funding, and now we're still working on it. So go ahead, Kaylee. Let me stop sharing.
Okay. Can everyone see that? Just making sure.
Yes.
Okay, good. All right. So I'm going to introduce you to the software that we use to perform tagging, and then give a brief workflow demonstration before passing it off to Brian. So in order to tag our text, we use CATMA. CATMA, an acronym for Computer Assisted Text Markup and Analysis, is a free and open source software hosted at the University of Hamburg, Germany, and it is easy to use without any coding experience necessary. It's been a great tool for curating a project's data set throughout the years, and the accessibility of its interface has allowed undergraduate student workers to easily transition from being new hires to integral parts of a project team. So when we open CATMA, this is what we see. The CATMA development team recently released version 6.0 of their software, though we have continued to use CATMA 5.0, which is the previous version that you see here, as our data is in migration. All of the text for our project are imported here into the CATMA repository and are listed as documents in the middle of the screen. These texts have previously gone through OCR and 2 rounds of proofing before being imported here into the repository for tagging. Tag libraries that are associated with these repository documents are found in the lower left corner of the screen. And for our project, we just have one tag library named FemControve. When we open the FemControve tag library, we can see all of the tag sets and tags that we've created. Tag sets are marked with a green diamond, and tags nest within tag sets and are marked with a red diamond. Tags are also associated with a color. With 2 exceptions, our tag sets are labeled and organized by text titles, and tags are labeled by characters. So for example, here we have a tag set named Desmond Names, meaning that this tag set is only used for a novel entitled Desmond, and the tags which are expanded underneath associate to characters within that novel. For example, Colonel Scarsdale, Lord Newminster, etc. When we tag by hand, we really strive to be thorough, which means including both minor and major characters in our data and recording any variation of their reference, honorific, or title in, reference, honorific, or name in the tag label. And because of this, though only 27 out of 90 of our volumes have reached this stage in the manual tagging process, it has resulted in over 800 individual tags. As I said previously, all of our tag sets and tags follow this organization with 2 exceptions. Those exceptions are our personality and activities tag sets. In total, we have 17 personality tags and 44 activities tags that can be used in all 90 volumes of our corpus. In general, tags found in the personality tag set describe who a character is, for example, education and temperament, while tags in the activities tag set are action words that describe what a character does, for example, arguing or not, or reading or not. Activity tags are labeled with the action word plus or not because we often come across double negatives in these 18th century texts. By including both options of performing and not performing an action in the same tag label, it's easier for text to be tagged correctly, even if the double negatives of the prose are confusing. So in order for our project team to be on the same page when we implement these tags, I created a tagging manual for all student workers and project managers to follow, and a few pages of that can be seen here. The manual mostly consists of color tables with detailed descriptions and use cases. For example, we have a tag named social status that is denoted by a bright pink color in CATMA, And the tag indicates the class rank, status, or reputation of a character in society, and will most likely be used if the following keywords are present in the text: high, middle, or low rank, station or situation, title, heir, and influence. Some tags in the taxonomy seem nearly identical to each other, so the final column in the manual, called related tags, can be useful in situations where two tags could reasonably be applied to the same bit of text. These situations are usually a question of whether to use a tag from the personality or activities tag set. For example, here in the personality tag set, we have a tag labeled physical characteristics, which relates to a tag in the activities tag set called emoting or not. Although both tags are concerned with what a character looks like, the tag emoting or not is more often used when the character is exhibiting a temporary expression or emotion, while the tag physical characteristics is used when the text describes the unchanging and defining traits of a character, or in the style, or in the case of their dress, when their style seems habitual and remains consistent throughout the text. Once a text has gone through the tagging process, it looks something like this. Different tags can be distinguished by their color, and tag layers easily stack on top of each other without obscuring the visibility of the original text. The tagged text is then passed on to the project manager for review. Then, once the project manager has completed all of their revisions, the text and tagging data is exported out of CATMA as an XML file and ingested into Corpora. So now I'll pass the presentation off to Brian so he can talk a little bit more about Corpora.
All right, thank you, Kaylee. Okay, let me get my screen shared here. All right. Okay. All right, so my name is Brian Tarpley. I'll be speaking about how we use a tool called Corpora to ingest, wrangle, augment, and query the data sets comprising the Feminist Controversy in England project, which I'll refer to as FemCon for brevity's sake.
Sorry, your screen probably is not really fully showed up.
Oh no, okay, I'm so sorry. Let me fix that real quick. I changed to a different monitor, so that probably was the cause. Here we go. Thank you for letting me know.
Yeah, that looks good now.
All right, Corpora is a tool we've been developing here at Coder over the last 5 years in order to service the research needs that we have when it comes to handling what at least we in the humanities refer to as large data sets. So for this reason, we refer to the tool as a data set studio for the digital humanities. And what sets Corpora apart is that, you know, it's a web application and it manages data sets across 3 different types of database. I guess you could refer to that as a multi-model architecture. We use MongoDB for storing and retrieving documents, Elasticsearch to enable searching, sorting, and aggregating quickly, but in a performant way, and Neo4j, which is a graph database for exploring the connections between various pieces of data. What you're looking at here is just a kind of quick sketch, almost like an entity relationship diagram of the FemCon corpus or data set. Currently in Corpora, we have only ingested 7 out of the 27 documents available for importing because we're still very much in kind of the planning phase of this sort of next part of the project. So we're just trying to import a representative amount of data into Corpora so that we can play with it and see what happens. Of those 7 novels, there's data for over 300 different characters. 61 of the different tags show up in those 7 novels that have been ingested. And we have something like 17,600 some odd taggings, which are moments when Kaylee or a member of her team have applied a tag to a moment in a text and associated that with a character. So that's roughly what our kind of schema looks like. from this point forward, I'm just going to kind of demo the rest inside Corpora. So this is something of a live demo. Hopefully, nothing will break. We'll see here. But I just wanted to show you kind of how that data looks like in sort of like a tabular format that people might be more used to seeing. Here are those kind of 7 documents that we have ingested so far, and the kind of 300 characters and, all of the taggings, right? Which again, associate kind of, a moment in the text from a particular novel with a character and a tag, all right? So that's what a tagging sort of represents. The reason why we kind of build this tool called Corpora, and we like to use it for our projects, is that it really speeds up our ability to kind of get up and running with the data set, allow other people to collaborate in editing and kind of creating data. And from a data science perspective, we like it because it's 100% written in Python, and it comes with a built-in IPython notebook. So you can kind of launch that notebook here and take a look. This is basically where I developed the kind of code that goes through and sort of reads in an XML file that Kaylee and her team has produced and saves it inside Corpora. And I'm not going to run through the details of that code, but for those of you who like to work in Python, you'll sort of understand why it makes me happy to be able to just sort of do all my work inside one tool. Here is just a quick demo. I'm grabbing a document and printing out the title to the screen. So it's a typical IPython notebook environment. Okay. I should say that the schema that we built to house this data was built also inside Corpora. It's just a simple kind of web form where you can build out the various fields belonging to each kind of type of content, etc. All right, so now that this data is inside Corpora, like what are some of the preliminary things that we could do in order to explore the data and sort of ask questions about it? So I'm going to formulate a very simple hypothetical question about the data. So for a particular novel called Eleanor, let me see here. I want to ask the question, all right, what are all the tags associated with the main protagonist of this novel, whose name is Eleanor Harcourt? And then I'd like to see who are the characters, other characters in that novel that share the most tags with Eleanor? And just as a way to start looking at some very basic kind of associations between different characters in the novel. So for this purpose, I'm going to pull up the sort of built-in network visualization that comes with Corpora. And I'm going to start sort of massaging this a little bit in order to more appropriately answer that question. For now, I'm going to hide keywords, which I will explain here in just a little bit. I'm going to hide all of these documents. And I'm going to do some things to the taggings to make sure that we're only looking at data that's relevant to Eleanor Volume 3, which is the kind of text in question. And finally, I want to restrict the characters to characters from that novel. I will also note that, if my goal is to see characters associated with tags, all right, there's sort of this intermediary data layer of taggings that we have to go through that actually creates quite a bit of noise in this graph. So I want to collapse that relationship to make it as clear as possible that we're just interested in the association of characters and tags. So I'm going to collapse that. I guess I see one tag set showing up, so I'll hide those as well. All right, now that I've sort of prepared the graph for us to ask that question, all right, I'm going to bring in all of the tags associated with this protagonist, Eleanor. Okay, and there are only 55 sort of tags that were associated with her via something like a few thousand taggings. And you can see that, you know, the way this network visualization works is that the size of the node is kind of corresponding to its degree, right? Like the number of connections that come out of that node. So obviously the largest node is our protagonist here. But you also see the thickness of the line can be different. And really what that's indicating is that there are a whole lot of taggings that associate Eleanor with this particular tag here, which is feeling. Okay. So I'm now going to, now that we have every tag associated with Eleanor on the graph, I'm going to look for every character, hopefully, that is associated with those tags. Now, because you know this visualization is built using the HTML5 canvas, it will sort of slow itself down for a second while all of the different network API requests are being resolved, and there's just sort of a whole lot going on. So it will take just a second to populate. But again, the goal here is to hopefully see that some characters tend to be tagged with like the most, there are some characters that share the most tags with Eleanor, right? So that's kind of the question we're hoping to answer through this visualization. Now, granted, there are obviously other ways to ask questions of data, query, write Python's code or whatever. But again, the goal of this tool is to provide researchers who might not necessarily know how to write in Python or come at the problem with some more computational methods, to give them just sort of a quick way of asking preliminary questions of the data. And here we see, right, that the second biggest node in this graph is this character right here. This is Lady John Dariel, also referred to as the Duchess. So it would seem that given all the characters and tags here, that this character here shares the most tags with Eleanor. All right. Now, can we draw any serious kind of scholarly conclusions from that level of information, that kind of query? No, not really. I mean, there could be 10 different reasons why these two characters share the same quite a few tags, right? It could just be that the author has written a whole lot about those two characters in this novel. So again, not trying to claim that we've made some huge claim here, just trying to show that the data is in shape enough for people to start asking interesting questions of it. So far, we've looked only at data produced by human beings. So, Kaylee and her team have manually tagged these texts, associated little snippets of text with a character and tag, etc. What we'd like to do kind of moving forward with this project is to augment it using more automated data, data that we can get from machine learning models or whatnot. And so as a kind of a first step in that direction, we identified a natural language processing pipeline, right, that unlike most pipelines, actually uses models trained on literary data, right? So you can go, for instance, look at the Spacey module for Python, and all of those machine learning models tend to be trained on like news articles or Wikipedia pages that have been scraped or something like that. We were lucky enough to identify first a tagged data set of natural language processing tags on literary texts, and a Python module that uses those models to basically under the hood run Spacey NLP, but just use this kind of more data more oriented toward literary works. We went ahead and ran that kind of NLP pipeline on this particular novel, which is Eleanor Volume 3. And so what I'm going to do is I'm going to ask that same question I just asked. What are some characters that might be that might cluster together with the protagonist of this novel. But this time, instead of relying on human-made tags, we're going to look at that NLP data set. So I'm going to, massage this again just to hide certain, get rid of the signal to noise kind of, or improve that ratio, such that we're really just kind of looking at characters and keywords. Now, how did these keywords come about? Well, as part of this NLP pipeline, right, the algorithm goes through and tries to perform named entity recognition and co-reference resolution, right, to identify all the moments in the text where a particular character is being talked about, right? It's doing its best to say that, in this particular sentence, right, the word duty appears and it's associated with this character, right? And, obviously, the NLP process isn't going to, just have a one-to-one correspondence with the characters that we've identified. So we do have a process where we map kind of the characters identified by NLP to the characters that we've identified manually through the process that kind of Kaylee has worked on. All right, so I'm gonna bring in, let's say, half of the keywords here because, for the sake of time, we don't need to sit here and watch me pull in all of this data. And again, the goal is to see if we can cluster characters together by virtue of them sharing connections to these keywords. Okay, so I'm just gonna sprawl these out. I'm gonna let it cook, let the visualization cook and stabilize for just a second. All right. And so, again, granted, we're only pulling in about half the data, but hopefully it's representative. And what we see, again, that the character that seems to share the most in common with Eleanor, just in terms of a commonality defined by do they share the same kind of verbs and nouns that get attributed to them throughout the novel? It would appear that that same character, Lady John Dariel or the Duchess, right, seems to have a lot in common with Eleanor. Okay, again, can we make conclusive arguments based on this? Absolutely not. We still need to look at, certain hypotheses, like maybe these are just the two characters that get talked about the most throughout the novel. So again, not trying to make, heavy conclusions, but just sort of demonstrating that we're in a place where we can do interesting things with our data. We can visualize it. We can quickly add new augment the data set with something like natural language processing. We implemented that. It took a few weeks to get kind of the book NLP pipeline to work in Corpora. And so what we're really coming to you as kind of the data science and machine learning folks on campus and asking, what can we do with the data that we have so far? Have we been making any mistakes? Is there a different direction we can go? What methodologies are out there for finding latent patterns in data that we hope might kind of emerge, and maybe some of these patterns we could call a gender, and that these categories that emerge from our data might represent historic gender categories from this period. Right. So I think that's it for me. But here, I will put up a slide that says thank you. And we're asking for questions and advice. There's our email addresses. If anybody wants to screenshot that real quick. But yeah, I think that's it.